So we're continuing to review rational expressions, and so in this video we're just going to focus on all of the ones that are asking you to solve for x. So the last video was all multiplying, dividing, adding, subtracting. Now that we know about all the operations, now we can solve. Right, so in this first problem, we have fraction equals fraction, and the math vocabulary word for when a fraction equals a fraction is that this is a proportion. And so when we have proportions, we can just cross multiply. This is something that you've done before with much simpler looking fractions. So I'm just going to multiply x minus 10 times 3x plus 4, okay, which I'm just going to write out to start. Okay, and that should be equal to the other direction, which would be 4x times 2x plus 1. Okay, so I have to just FOIL out the left, FOIL out the right, and let's see what happens. It looks like 3x squared. I get negative 30x plus 4x. Negative 30 plus 4 looks like negative 26x. And then negative 10 plus 4 is negative 40. Okay, on the other side, it looks like I get 8x squared, okay, and plus 4x. Okay, so now I need to solve this, and remember, anytime that there's a squared in the problem, my goal is to set it equal to 0 so that I can either factor or use the quadratic formula or use completing the square or any of the other methods we have at our disposal. So I'm going to subtract all of the stuff on the left over to the right. And the reason that I'm choosing to do it in that direction is because I'm noticing that when I do 8 minus 3, I'll end up with a nice positive x squared value. And I always like my leading coefficient to be positive. It makes factoring a little bit easier. So I'm going to subtract everything from the left over to the right. And so the left is going to become 0. So 8 minus 3 becomes 5x squared. 4 plus 26 looks like this is going to turn back into a 30x. Okay, and then I'm going to add over the 40, and it's going to look like that. Okay, so now I have to solve this. It looks a little bit nicer, and I'm noticing that there's a 5 in all of the terms on the right. So I'm going to divide the entire expression by 5, and I'm going to divide the right hand or the left hand side by 5 as well. 0 divided by 5 is still 0. And I end up with x squared. 30 divided by 5 is 6, and 40 divided by 5 is 8. Okay, and so this actually factors really nicely. I don't even need to use AC factoring. And I can turn this into x plus 4, x plus 2. Okay, and it looks like I get two solutions. I get a negative 4, and I get a negative 2. Both are answers, right? And remember that when we're doing problems involving solving with rational expressions, it's possible that we might have an extraneous solution. So let me remind you in this context what an extraneous solution is. An extraneous solution in general is just anything that looks like an answer, right? We have these two solutions, but that maybe when I go back and I plug it in, doesn't make the original expression true. Okay, so for rational expressions, when we're solving problems that look like number 10, that's going to happen when the values that come out at the bottom, when I plug them into the denominator, make them turn into 0. Right? So we can't have undefined expressions in an equation. So negative 4, when I plug it in here, definitely doesn't turn it into 0. And when I plug it into this second denominator, also not 0. So I'm good. Negative 2, same thing. It's not an issue. They're not going to turn either of these fractions into 0. So I'm going to say both of these are actually valid, good answers. I'm going to keep both of them. Right, but we just have to do that check and make sure that there's no undefined expressions when we find our x values. Okay, so move on to the next problem. This one's a little bit more work. Right? I'm looking at this one and I'm saying this does not look like fraction equals fraction. And so the first thing I need to do is to combine the left-hand side, right? Or at least get common denominators on the left-hand side. So here's the way we're going to handle this problem. We're going to say, if I can turn all of these expressions into the same denominator, okay? In this case, the common denominator, we've done this, x minus 2 and x plus 2. Okay, and I want this one to be x minus 2 and x plus 2. Okay. And on the other side, on the right-hand side of my equation, when I factor x squared minus 4, I already have x minus 2 and x plus 2. So I don't need to change that one as well at all. So the one on the right, my fraction on the right-hand side is going to stay just like it is. It's going to look like 4x squared. I am going to have to take my 3 that was already in the numerator, and I'm going to look and say there was an x minus 2, so I'm introducing the brand new x plus 2 up here. Okay, that's what I introduced in the denominator. Same thing's going to happen with the second one. There was already a 5. And so now I'm going to say, well, it had an x plus 2, so this x minus 2 is new down here, so that's what I'm going to introduce up here. Okay, so here's what we said. And I'm going to show you this again with a regular simple problem. If I get it to look like this, where all the denominators match each other, it would be something like this. If I had 3/5 plus 7/5 equals 10/5. Okay, the denominators all match, and so I'm going to kind of look at this and say, because they all match each other, they're really irrelevant to my problem, right? So I'm going to look at this and say, I really just care that 3 plus 5 equals 10 without considering the denominators at all. So I can do that in my problem as well now. I can say x minus 2x plus 2 is in all of my denominators, so it's really irrelevant to my equation at the moment. It doesn't matter what they are, it just matters that they match each other, right? So we can redo this problem, and I'm going to say that let's just rewrite the numerators. 3 times x plus 2 plus 5 times x minus 2 should be equal to 4x squared, in the same way that in that other problem I just said that 3 plus 7 is equal to 10. That's really the important part of this problem, and in this case, our numerator is the important part of the problem, because the denominators now match each other. So this is pretty straightforward to solve. I can say this is 3x plus 6, okay, 5x minus 10, and still a 4x squared on the right-hand side. So I'm going to subtract everything over to the right-hand side. Again, I want to keep the 4 positive if I can, because that's my leading coefficient. Right, so if you do the simplifying, this is 3 and 5, 8x that I'm going to subtract over. So it's minus 8x. Okay, and I have a 6 minus 10, which is negative 4, which again I'm going to add over to the other side. Right, so again I got this situation where everything divides by 4. So I'm going to call this now x squared minus 2x. Okay, let's fix that. Okay, x squared minus 2x. Getting a little ahead of myself. Minus 2x plus 1. There we go. Alright, so now this factors again nicely into x minus 1 and x minus 1. And so I really only get one solution here, and that is 1. Okay. Again, let's do a quick check and make sure that 1's not a bad value. If I plug in a 1 here, good, not 0. If I plug in a 1 here, that's a 3, that's fine. If I plug in a 1 here, it looks like negative 3, I'm good. Right? So in this case, 1 is not an extraneous solution. It does not turn the denominators into 0, and I'm going to keep it. Okay, but the big idea with this problem was I found common denominators, and then once the denominators matched each other, I could really just consider the numerator part of the problem. That's the only thing that I brought down, and it made it a lot simpler problem to deal with. Okay. So we have a couple more problems that are in this similar type of vein. Okay, so we'll go through each of these just to give you some more practice with this one. So if I'm looking at number 16, I'm going to say it looks like x plus 3 is what I want to be in my denominators. There's nothing else in the denominator. So the first expression's fine. I'm just going to leave that one alone. Okay. My second one is not fine, and 1 is really just x plus 3 over x plus 3. So I multiply the top and the bottom of this. Remember, this is like over 1 by x plus 3's. Right, and I end up with the same thing in the numerator and the denominator, which makes sense for 1. Right? And again, I don't need to change this last one. Okay? So again, denominator, denominator, denominator. They're all the same. That's good. So that means that I can really rewrite this problem and say this is really 2x minus x plus 3, and that should equal x. Okay? So let's subtract. This says 2x minus x. Well, 2x minus x is just x minus 3. Okay, equals x. Okay, and so a weird thing happens here. If I try to get the x's together, when I subtract the x away on the left, I also subtract it on the right, and I get this happening. 0, right? X minus x is 0. It's not 0x, it's not just 1x, it's 0. Everything's gone. And so I get this weird thing that is not true. Negative 3 is not equal to 0 ever. So when this happens, I'm going to say this is a case where there's no solution. Okay? This doesn't exist. We can't ever have negative 3 equals 0. This is false. Right? And so it kind of made sense right here. Look what I'm asking to be true. I'm asking you to tell me that if I take x, some number, and I subtract 3, that I should get the number back. And that doesn't make any sense at all. I can't take 3 away from anything and end up where I started. So it didn't make sense at this step either. So this is kind of a nonsense problem. And we're going to say there's no way for this true. You can't find an x value that you can subtract 3 from it and end up back where you started, right? So this is a no solution problem, and it's entirely possible when you're solving these that you might end up with no solution. Okay, so here's your last one. So I'm going to say in this case, looking at my 3 denominators, that it looks like 3 and x plus 2 need to be in all of my factors. I'm sorry, in all of my fractions. So my common denominator is 3 times x plus 2. So I just introduced a brand new 3. So this is really 3 times 3, which is 9. Okay, my second fraction looks like it needs to have both pieces, right? If there's just a 1 down there, it doesn't have a 3 and it doesn't have an x plus 2. So both of those are going to show up. So it's really going to become 3x times x plus 2 over 3 times x plus 2. Okay? So I just wrote this a little funny. The x is the x that was showing up here. I introduced a brand new 3, and I introduced a brand new x plus 2. And on the right-hand side, it looks like I have the 4, and I'm introducing the x plus 2 up top. Okay? And that means I'm going to have a 3 and an x plus 2 in the denominator. Okay? So let's, again, look at the denominators. They all match each other, which means now I don't even need to think about them. I can just really say that the numerator here, 9, plus, and I'm going to distribute as I go, this is 3x squared plus 6x, should be equal to the right-hand side, which is 4x plus 8. Okay? So in this case, I'm going to bring the stuff on the right over to the left because, again, the x squared is my leading value in standard form, and I want that to stay positive. So I'm going to subtract all this stuff over. So it's going to look like 3x squared, okay, and then 6x minus 4x is 2x. Okay, and then when I subtract over the 8 to be with the 9, I get a positive 1. Okay, and so this is my problem now. So I'm looking at this, and I'm trying to figure out how I could maybe factor this. Right? And it's possible that it will factor. So it looks like I have an AC value of 3, and I'm saying what multiplies to 3 that adds up to 2, and I'm kind of saying like I can't think of anything. There's really nothing that multiplies to 3 that adds up to 2. Right? So in this case, I'm going to use the quadratic formula because it might factor. Maybe I missed something, but I can just as easily just say negative 2 plus or minus. Remember, b squared is 4 minus 3. I'm sorry, 4 minus 4. Let me fix that. I missed my 4 in 4AC. Okay, so it's 2b squared minus 4ac all over 2a would be 2 times 3, which is 6. Okay, so x equals this expression. So we're almost done. We just got to simplify, and here's what happens in here. This says 4 minus 12. Well, 4 minus 12 is negative 8. So I end up with a negative in the radical. Okay, so negative 2 plus or minus negative 8 over 6, right, the square root of negative 8 over 6. And this is one of those, for our x values, we're going to say there's no real number solutions, but let's simplify it into I anyway. Right, we can still do that. So this is going to become negative 2 plus or minus 2I root 2 all over 6. Okay, which simplifies a little bit more because I see 2's happening everywhere. So final answer using I, negative 1. Let's get rid of that. Negative 1 plus or minus I root 2 all over 3. Okay, so again, we would say there are no real number answers to this, but we can at least use the quadratic formula and find out that it has 2 complex solutions. Okay, last problem. So we have our application problem. I'm giving you a geometry problem, and I'm asking you what is the area of the triangle shown at the right. So if you remember when we're doing area of a triangle, the area of a triangle is equal to 1/2 the base times the height. And in this problem, this is my base and this is my height. Okay, so I'm just going to plug those values in. My area is 1/2. Okay, my base is 2x plus 8 over x squared minus 9. And my height is x plus 3 over x minus 3. So now if you take a look at this, as ugly as my problem looks, let me just clean this up a little bit. Okay, if you take a look, this is really just a multiplication problem, multiplying with fractions. So we're going to say, let's factor the numerator, which only this first one has any factors besides 1. So I'm going to say 2 times x plus 4, okay, over, and then the denominator x squared minus 9 becomes x plus 3 and x minus 3. Okay, and then my second fraction doesn't simplify at all. It's just x plus 3 over x minus 3. Okay, so again, you might be thrown off a little bit by all these parentheses. These are just, instead of using the dots, we're using parentheses. So I'm going to say anything in the numerator and anything in the denominator. So I see in this case an x plus 3 and an x plus 3. I see a 2 and I see a 2. And I don't see anything else in common. So don't be thrown off by these x minus 3's. They are both in the denominator, which means we cannot cancel them. We can only cancel one thing in the numerator with one thing in the denominator. So here's my final answer. If they want to know what is the area, the best I can do is give them an expression and say x plus 4 in the numerator and x minus 3 times x minus 3, which I'm going to write as x minus 3 squared in the denominator. I'm going to say this expression represents the area of this triangle. If you give me an x value, I can plug it into this expression and I will get the area of the triangle.